Thank you very much to our organizer for inviting me to present our recent result during several years that we got several years. And it's the result of our activity, cooperation of three organizations, Kotelnikov Institute of Radio Engineering Moscow, Max Planck Institute Stuttgart, and MISIS is Moscow National Research University of Technology. Before, I just to mention that before we discuss the problems, I would like to pay your attention that the using of spin current and generation and the detection of spin current is very important, especially for solve the problem of heat dissipation. And in our investigation, we paid attention to the heterostructure consists of two materials, and we believe that it's a very interesting system, very interesting structure for solving the problem of generation of pure spin current and its detection by using of inverse spin Hall effect. Why we select this composition of manganite and iridite? Manganite is a rather well investigated material. It's ferromagnetic with optimal doping, with Curie temperature about 350 K, and magnetization quite big, quite high magnetization at room temperature. Manganite is a 3D transition material, and it has strong electron-electron correlation. On the other side, iridite, that's strontium iridium 03, is a 5D transition material, and it has a strong spin orbit interaction. It is very important for conversion of spin current to the charge current. Both manganite and iridite have a perovskite type crystal structure, and the crystallographic parameter is rather close to each other. How we fabricate this structure? It grows epitaxially by means of deposition technique like Raffman neutron sputtering on the substrate of neodymium gallium. Neodymium gallium 3 temperature is about 800 Celsius. Oxygen is 0.5, 0.3, 0.7 millibar. And material deposition, this is stoichiometric targets. You use manganite and iridite. Typical thickness of the fumes is quite small, is from 5 to 50 nanometers. It's just an illustration, this Bragg scattering, X-ray Bragg scattering picture that illustrates that all composition present at this structure, and moreover, from the tilting investigation and T-scan, we can conclude that the growth of this material looks like cube to cube. That's the cubic of quasi-cubic of iridite is parallel to quasi-cubic axis of manganite, and all of them parallel to neodymium gallium. Parameter between iridite and manganite. And also we observe some changing of angles and axis during the lowering of temperature. Also, we investigate this heterostructure in order to understand ferromagnetic property. What's happening? The first one, we observe anisotropy of this structure, and that's anisotropy is dependent on the temperature, and besides we have cubic anisotropy typical for this material, and also uniaxial anisotropy due to the influence of the substrate, and we observe increasing of cubic anisotropy with temperature, while uniaxial anisotropy is changed not too much. What's interesting happen if we deposited CO on manganite, if we deposited iridite on manganite, what's happened? It's increasing of line widths, and that's indicate the line widths for material for investigation is platina, garnet, iron, gallium, yttrium, garnet. Sorry, this I miss it. And it's we see that difference is not very high, but this is one of the best value obtained for this structure. I would like to know that really this value is changed significantly for different publications. Charge current in this system is determined by the spin Hall angle and depend on the current of spin current just proportionally. So that's I would like to pay your attention to that for observing this effect, voltage appearing of charge current in the system, and it looks like this just a straight. We should have proper orientation of the external field, microwave field, and current. So that is this one shown, and it's depend on the if we have the two orientations proper, that we have dependence on the angle phi 2. But that is a picture where we show the response that we obtain in our system. It's dependent voltage on the magnetic field, and in resonance in the area of ferromagnetic resonance, we observe increasing of voltage across this our sample. And but what's interesting